In this video, we're going to talk about double displacement reactions and double displacement reactions containing polyatomic ions. This is just a reminder, a double displacement reaction, A will end up with D and B will end up with C. It's a double displacement. So we're going to be doing chemical reactions in lab, and in chemical reactions, you might see a solid form, a temperature change, bubbles are made, color changes, or even explosions. Hopefully not in the lab. So these are going to be things that we would see if there is a chemical reaction. One of the things that we need to talk about are the phases to a chemical reaction. So if you're looking at pure NaCl, that's table salt, you'd tell me that is a solid. So in our chemical equation, I'd say NaCl solid. If you had to describe this, would you call it a solid, liquid, or gas? Hopefully you would call that the water inside it a liquid. And then when you dissolved that table salt, sodium chloride, in the water, it's in water right here, we use a term, so sodium chloride is dissolved in the water, and we say it's aqueous. So it's a little bit weird because we have pure water, we call it a liquid, but if something's in water, we call that aqueous. Aqueous means it's dissolved in water. It's in the water solution. And a lot of times you can't even tell it's in there, but it's in there. Sugar water, salt water, etc. Okay, so what the heck is happening? We can't see the whole beaker over here, but there's another beaker, and they're pouring the contents from that beaker into this beaker. In the one that's being poured is barium chloride. And in the receiving one, we have Na2SO4. And you can see as you pour it, a solid is crashing out of solution. When a solid crashes out of solution like that, we call it a precipitate. I guess crashing sounds so extreme, but it is a precipitate. Comes out of solution, solid forms, however you want to say it. A solid, when it is clear and then all of a sudden it comes out of solution, that's called a precipitate. Just like snow is precipitation. Okay, so this is what's happening. That's our reaction that is happening. We're adding one thing to the other, and it's a double displacement. So let's track where things are going, because now we have a polyatomic ion. And with polyatomic ions, we want to just find them because they're multiple atoms, and so we don't want to get lost. So here's my SO4 here. And it ended up, and it was with the sodium, and it ended up with the barium. Here's my chloride over here, and it ended up over there. So you can see the barium. Oops, I wanted that to be a pretty highlight, but it was not. The barium ended up with the sulfate, and the sodium ended up with the chloride. So the sodium ended up with the chloride. The first one is always going to end up with the last one, and the middle two are going to end up together. So they swap. Okay, so I'm not going to ask you to predict the products, but you could just for fun practice it. This will go with that, and this will go with that. But really, we just want to keep our eye on the prize. This is a double displacement reaction, and I am keeping track of this polyatomic ion. Okay, so now we are going to balance the equation. We're going to balance the equation. Honestly, these aren't too tricky as long as you first recognize your polyatomic ion. So I look at my polyatomic ion, and I've given you a list down here. Here I have my SO4. SO4, here's my SO4. And over here is my SO4. So I'm going to keep track because I'm going to keep them as a unit when I balance things. I have a chloride and a chloride and a sodium and two sodiums, right? And a barium. Let's give barium pink. pink, and pink. I have 2 chlorines. So visually, I can see that they're not balanced. But let's do our little atom table. So if I'm doing an atom table and I don't want to just do it visually, I would say, actually, let me make this nicer. So I'm going to put my reactants here. It's just so I can like visually go from here to here. So I have the atom or polyatomic ion, reactants, and products. So notice that I'm not counting the number of oxygens because I'm considering that a whole unit. So I have barium, chlorine, sodium, and sulfate. I'm keeping the whole sulfate together. I'm not putting charges on any of these things, just tracking the actual atom itself, what's happening. So barium in the reactants, I have one, just one of those, and just one of those. Chlorine, I have 2 because of the subscript 2. And in the products, how many chlorines do you have? So in the product, how many chlorines do you have? You should have told me 1. Sodium in the reactants. How many sodiums do I have? Well, I have 2 sodiums. So 2. And in the product, how many sodiums do you have? 1. And how many sulfates do you have? In the reactant, you have 1. And in the product, you have 1. Okay, so I see where I need to do my work. It's going to be right here with the chlorine and the sodium. So I have 2 sodiums on the left, boop, and I need 2 sodiums on the right. So I'm going to put a 2 in front. When I put that 2 in front, that means I have another NaL, an Na, and a Cl. So I have another Na, and I have another Cl. That 2 that one turned into a 2, and that one turned into a 2. And boom, it's all balanced. So it's not terrible, just recognizing that in these double displacement reactions, those are going to be a unit of something. So I don't need to put a 1 here. I don't need to put a 1 there because it's understood. Okay, so let's look at another double displacement reaction. So I have barium, and I started off with chlorine. There's chlorine on the other side. Sodium, I have 2 of them because of the subscript. Sodium, I have 1. And sulfate, whole unit, sulfate. Okay, so reactants. Oops, I don't know why I'm not feeling that color. I just want black. So I have reactants, products, Ba, Cl, Na, SO4. And notice this is after they've added a little bit of they've combined these 2 things. You can see some solid is coming out. And that's exactly what this little solid is there. So they've combined barium chloride and sodium sulfate, put those 2 things together, and we get to see this coming out. Sodium chloride is table salt. It's just going to be clear. We're not going to be able to tell anything's going on there. Okay, so that's what happened. I didn't describe what happened before I got started. That's what happened. I combined 2 things and this crashed out. So the chemical equation talks us through that, and I need to make sure it's balanced. So on the left, bariums, I have 1. On the right, bariums, I have 1. On the left, chlorine, I have 2. On the right, chlorine, I have 1. So you're already like, oop, I'll be back for you. On the left, sodium, I have 2. I have 2. On the right, sodium, I have 1. So notice that one too. I'm going to have to come back to you. Sulfate. Sulfate, I have 1 and 1. 1 and 1. Okay, so I have 2 sodiums on the left. 2 sodiums on the left because of the subscript. I need another one over here. So to bring in another sodium, it comes in the form of sodium chloride. I have to put a 2 in front. When I put a 2 in front, that makes a whole thing, a whole nother NaCl. And so now I have 2 NAs and 2 Cls. And then everything, I just check, double check, and I have my balanced reaction. So that's it. For 1 barium chloride and 1 sodium sulfate, I get 2 NaCls and 1 barium sulfate. All of these, the ones, I don't need to write them down, but they're understood. Okay, so here's another reaction. What the heck are we looking at? Well, we are looking at potassium hydroxide. We can't tell it's in there, but it's in there. Nickel chloride, it's pretty, and I'd call it light green. It's a pretty color, clear. KCl is in solution, and it forms, this is what it looks like. This is actually what nickel hydroxide looks like if we had it not in solution. But when it precipitates out, it looks like that. So I have the solution, it's kind of green, and then the solids inside there. Okay, so that's what happened. We combined two things, and we did a double displacement reaction, and we got this really cool nickel hydroxide precipitate. So let's balance the equation. First thing you're going to look for, when you look at KOH, it's kind of deceivingly, feels like it's going to be small. You're like, ooh, K plus, but what the heck is this OH? You have to recognize it's a polyatomic ion. So I'm going to group it. Polyatomic ion OH, polyatomic ion OH. There it is. I don't have any other polyatomic ions. So let's do reactants and products. And what do I have? I have a K, OH. I keep the polyatomic together. Chlorine and nickel, I'm not putting the charges because I'm just balancing it. Just keeping track of the atoms. For the reactant side, how many Ks do I have? 1. On the product side, how many Ks do I have? 2. For the OHs, how many OHs do I have on the left side? I have 1. On the right side, how many do I have? I have 2 OHs. I have 2 OHs. Okay. How many chlorines do I have? I have 2. How many chlorines do I have on this side? Hopefully you said 2, because 2 KCl's mean I have 2 of these. I have 2 KCl's. So Cl's I have 2, and Na, dang it, that's not Na, it's a nickel. Nickel and sodium are not even close to the same. Nickel. So how many nickels do I have on the reactant side? I have 1. And on the product side, I have 1. So I can see this one's good, this one's good, and this is where I need to fix it. I have 2 Ks on the left side, or sorry, on the right side on the product side. So I need 2 more Ks. I need, sorry, 1 more K and 1 more OH. The nice thing is that comes as a whole unit. So all I need to do is put a 2 in front. When I put a 2 in front, that means I have KOH and KOH. So I have 2 Ks, 2 Os, and an H, right? Keep that together. So by adding the 2, boom, my reaction is now balanced. So I'm just going to erase all this extra crud, and I have 2 KOHs, 1 nickel, it's understood, 2, I don't know why that 2 was already in there, that shouldn't have been in there, but it was, so I was like, okay, well, I accidentally must have left it in there, and a 1 in front of the nickel. We're balancing equations, double displacement reactions, and we're always looking for our polyatomic ions, so we can just call it a unit, group it together. Okay, so here we go. I have barium chloride, no polyatomics. I have carbonate, that's a polyatomic ion. Carbonate, that's a polyatomic ion. And ACl's not. And we're really going to see these in these double displacement reactions. That's where I look for them. Okay, let's balance it. So we'll have Ba, and we'll have Cl, Na, and CO3. Again, I'm not including the charges, not because they're not there, but because we just don't need them for balancing equations. And reactants, products. How many barium do I have in the reactant side? Just one. How many barium do I have in the product side? Just one. How many chlorine do I have in the reactant side? Two. How many chlorine do I have on the product side? Well, there's already a 2 there, so that told me I have 2 NaCl's, which means I have 2 chlorines. Okay. How many NAs do I have on the reactant side? I have 2. And I have 2 on the right side. And how many barium? Carbonate, 1 and 1. This is already a balanced reaction. So yes, yay, already balanced, already balanced. Why are we doing this one? Guess just to see it's already balanced. Okay, yay. This one's not balanced because there are no coefficients in front whatsoever. Let's do it. So the tricky part of this one, and look at, I didn't even give you how mean. Notice your polyatomics were not given to you at the bottom. Okay, but it's okay. NH4, you look, is this a metal? Metals are always written first, right? This is not a metal. This is a polyatomic. So my polyatomic 1 is my ammonium. And my other polyatomic ammonium is here. OH is also a polyatomic ion. OH is also a polyatomic ion. And in this case, I noticed, ooh, I have 2 OHs. That's what that 2 means. I have 2 of these. And should we just color code the whole thing? We're almost there. So 1 manganese and 2 chlorine. Chlorine. Okay, so let's balance the equation. Reactants, products. I have NH4. It's on both sides, so I'm going to keep it together. Oops. I'm just going to be consistent, not include a charge. I have OH, I have Mn, and I have Cl. How many NH4s do I have on the reactant side? 1. How many NH4s do I have on the product side? 1. How many OHs do I have on the reactant side? 1. How many OHs do I have on the product side? 1, 2. Because of the subscript, I have 2. How many manganese do I have? 1 in each. And how many chlorines do I have on the reactant side? You should tell me I have 2 chlorines, 2 Cls, because of that 2 right there. That's what that tells me. So I have 2 chlorines. And on the product side, I only have 1. Okay, so this one actually already looks a little bit trickier than the other ones we've done because you'll see. So where do I start? It really doesn't matter because I have 1 of something in every single one of these. So it's not like I can avoid 1. So let's just start from the top. NH4 is already balanced. OH on the product side has 2 and only 1 on the left side. So we need more OHs. I can't just add a 2 here. If I tried to do that, no, you're not allowed to do that. I have to put a 2 out in front. A 2 out in front means I need that I have 2 of these. Okay, so now I have 2 OHs. Hey, and now I also have 2 NH4s, 2 ammoniums. And then I'm like, oh, okay, well, now the NH4 is not balanced anymore. I only have 1 on the product side. I only have 1 on the product side. So I'll put a 2 in front. And the 2 in front means I have 2 of these NH4 Cls. Okay, so that became a 2. Now my Mn is 1 and 1. It's still balanced. My chlorines, I actually should have been more careful when I added the 2 in front. This became a 2. And that became a 2. So my chlorines are balanced. I would check it one more time. So I could even just erase it just to make sure it's all perfect. So I have a 2 in front. That means I have 2 of these and 2 of those. I have 2 NH4s and 2 OH minuses. I have a 1 understood in front of the MnCl2. So 1 Mn and 2 Cls because of that subscript. I know I have 2 chlorines. And then I have 2 in front. So 2 NH4s and so 1 of these, 2 of those, 2 of those, 2 Cls. My Mn, I have 1, so 1 Mn. And because of the subscript, I know I have 2 OHs, 2. Okay, that is balancing chemical equations with polyatomic ions in a nutshell. I think it can be a little bit intimidating, but once you start just highlighting those polyatomic ions, honestly, I've seen you guys balance worse already. So you can do it. I'm going to let you do this one on your own. It's actually a really cool reaction. And I put a little video in your assignment so you can see it. Okay, see you in the next video.